Hello everyone. In this activity, we are tasked with the practical creation and systematic documentation of specific bloodstain patterns. We are going to perform the controlled simulation to produce various bloodstain patterns. But before that, I am going to introduce first the materials that we will be using for this activity and the ingredients. So first we have the wipes to clean the mess. We have the sponge and we have also the syringe and we have also the brush, the steel tape and we have also the wood and the measuring tape and the tiles and we have also the plain glass and the cornstarch and we have the yarn and the evidence stands and we have also the push pins and the masking tape and we have also the scissor and the dropper and we have also the ruler and the protector and we have also the color powder that we will be using to create a fake blood later and we have the magnifying glass and we have also the ingredients that we need, which is ketchup, and we have also the Nescafe and we have also hot water and the bond paper and we have also the cloth, the evidence bag and the plain curtain and we have also the board. And this is all the materials and the ingredients that we will be using for today's activity.
Now let's proceed to making our artificial blood. First, we're gonna add a cornstarch to our beaker. Then we're gonna add a warm water. Then we're gonna stir to mix the warm water and the cornstarch. Then we're gonna add a ketchup. We're mixing it all together. Then we're gonna add a coffee to reach our stickiness. Gonna add more because I want to reach the texture closer to our blood. Then we're gonna add a coloring. And we're gonna see if it reach our prepared color. I'm gonna stir and stir more. We're just gonna keep stirring. We're almost there. Now we're adding color green to make it darker. Then we're now going to test our blood using our dropper, and we're gonna drop the blood into our glass. So this is our glass. Try our drop, and we're going to look at our drop to see if it's really close to real blood. We're going to the non-porous surface.
Single drop. A single drop is a one drop of blood that falls into one spot. It's usually round in shape and it's caused by gravity when a person is bleeding but not moving. So now let's proceed to measure the width and the length of the single drop by using two rulers.
Let's proceed to the blood pool in non-porous surface.
A blood pool on non-porous surface is when the blood collects on top of the smooth materials like glass or tiles. It forms a smooth shiny puddle and does not soak into the surface. A blood pool in a cloth is when the blood soaks into a fabric and spread out. It looks uneven with a blurry edge because the material absorbs the blood. A blood pool on a porous surface, like a concrete wall, is when the blood is absorbed into the materials. It spreads out, looks dull, and has an uneven edge because the surface soaks in the blood. A blood series is a group of blood drops that form a trail. It happens when a person is moving while bleeding. It can show the direction they went. So how to measure a blood series? A blood series is measured by checking the distance between the drops, the direction shown by the pointed ends, the size of the drops, and the path of the trail. These help show how fast a person was moving and where they went. A flow pattern is when the blood moves or runs in one direction because of the gravity. It usually flows downward on the surface like walls or floors. This pattern can show the path the blood followed and may help indicate how the bleeding occurred or how the body was positioned. So how to measure flow pattern? To measure a flow pattern, check the direction of the blood and use a ruler to measure how far it has flowed from the starting point. This shows how the blood moves. An impact pattern is a type of projected blood stain that happens when the blood is struck by a force. This force breaks the blood into many small droplets, creating a fine spray on nearby surfaces. How to measure an impact patterns? To measure an impact patterns, check the size, spread, and direction of the droplets and use a ruler to see how far they are from the source. Cast-off pattern happens when the blood is thrown from a moving object like a swung weapon. It creates lines or curved marks on the surface and it can be shown the direction of movement. To measure the cast-off patterns, check the direction and spacing of the stains and use a ruler to measure how far they are spread to understand the movement. An arterial pattern is a type of projected blood stain that happens when an artery is damaged. The blood comes out strong, pulsing spurs, creating a patterns that follow the heartbeat and show direction. To measure an arterial pattern, check the direction, distance, and the spacing of the spurs and use ruler to measure how far the blood traveled. Contact patterns. A contact pattern is made when a bloody object touches a surface. It leaves a clear mark that shows the shape of the object. Directionality. For a contact patterns, you measure the size of the shape of the mark and check its position on the surface. Direction is usually not shown clearly because it's just a touch, not a movement. Swipe patterns. A swipe pattern is a type of blood stain that happens when a bloody object moves across a clean surface. It leaves a smudge mark that shows the direction of movement. Directionality of a swipe pattern shows where the object moved. The stain is usually heavier at the start and lighter or thinner at the end. So the movement goes from dark or thick area towards the lighter or faded area. Swipe pattern. A swipe pattern is a blood stain that happens when a clean object moves through wet blood. It removes or smears the blood, leaving a lighter or broken area that shows where the object passed. The directionality of a wipe pattern shows where a clean object moved through the blood. It goes from a lighter area to where more blood is pushed or spread. In this part, we use a steel tape to measure a 3 feet tall to drop a single drop with a 90-degree angle. As we observe, we see a parent drop with a satellite in a porous surface. A parent stain is the main blood spot where the most of the blood is found. Spines or scalloping are the uneven or pointed edge around the main stain, made with blood hits a rough surface. Satellite spatters are small blood drops that break away from the main stain and land around it. To measure a blood stain, use a roller to get its length and width for a parent stain. Measure how far the spine extends from the center. Check the distance satellite spatter from the main stain. A blood pool in non-porous surface. A blood pool is a large amount of blood that collects in one place, usually when a person is not moving and the blood flows out slowly. It forms a big, smooth stain on a surface. A blood pool in unobserved surface. A blood pool soaks in the material, making the edge looks blurry and spread out instead of smooth. So, in this part, we'll observe the changes and measure the width and length of the 3 drops of blood in each feet. As we observe in 1 foot, the blood is consistent and it has no satellite. Same as the 1 foot, the 2 feet has a consistent blood and no satellite. 3 feet is also the same as the 2 and 1 foot. It has no satellite, but the length and width are much larger. Forfeit is also the same with others. It has a consistent blood drop and has no satellite. Part 5. The geometry of angles of impact. The geometry of angles of impact help us know how blood hits a surface. If the blood drops straight down, the stain is round. If it hits an angle, the stain looks longer or oval. To find the angle, we use this formula. The width is the short side of a stain, and the length is the long side. If the stain is more stretched, the angle is small. If it's more round, the angle is bigger. This helps investigators know the direction where the blood came from. Part 6. Tracing the source or 2D to 3D reconstruction. Tracing the source of the blood means finding the exact place where the blood came from. First, investigators study the blood stain on flat surface or 2D, like walls or floors. They look at the shape and direction of each stain. Then, they draw the straight lines following the direction the blood traveled. When these lines meet on the surface, it shows the area of convergence or the general directions where the blood came from. Next, they move to 3D reconstruction. They use angle of impact just like we do to our part 5 of each blood stain to project the lines upward into the air. These lines are the visible path showing how blood moved. When the lines met above the surface, it shows the area of origin, which tells the height and the exact position where the blood was released. In simple words, investigators first find where the blood points on a flat surface, then extend those directions upward to find the real source in space. This helps them understand what happened during the incident.